Ever wondered how AI is becoming a real partner in scientific discovery? Let's break down how researchers are teaching machines to do data science, and how a new system called AUTOMIND is redefining what's possible. Data science is the art of transforming messy, unstructured data into actionable insights. But it's far from simple. It's like solving a 1,000-piece puzzle where each piece represents a different tool, technique, or decision. Traditional AI systems tackle this by following rigid predefined workflows, much like a recipe. But here's the problem. They're stuck using the same approach for every challenge, even when a different strategy would yield better results. That's where AUTOMIND shines. Instead of a one-size-fits-all approach, it combines two groundbreaking ideas. First, it leverages a vast repository of human expertise. Think solutions from Kaggle competitions or peer-reviewed research to give the AI a head start. Second, it employs a dynamic coding strategy that adapts in real time, like a chef improvising a recipe based on available ingredients. The results? AUTOMIND outperforms state-of-the-art systems by staggering margins. In key benchmarks, it surpassed 45.4% of human participants in one test and 56.8% in another. But here's what's even more impressive. It's not just about speed. By integrating real-world knowledge and flexible problem-solving, it begins to mirror how humans approach data science, iteratively, creatively, and with a touch of intuition. Of course, no system is flawless. Researchers had to simplify tests due to computational constraints, and AUTOMIND still struggles with highly complex coding tasks. But these are hurdles, not roadblocks. The bigger takeaway: when we blend human expertise with AI's speed, we're not just automating tasks, we're accelerating discovery. So next time you hear about AI solving a problem, remember, it's not just about raw power. It's about learning from the best, both human and machine. And systems like AUTOMIND are proving that the future of science might just be a collaboration between minds, old and new. Now, let's pull back the curtain on a groundbreaking study pushing machine learning to its limits. Imagine a giant toolbox filled with 20+ unique puzzles, each testing AI's ability to adapt. This is MLE-Bench, a testing ground where models face challenges ranging from classifying pizza images to predicting volcanic eruptions. These puzzles vary wildly in data size, complexity, and rules, with some using 31 gigabytes of signal data and others just 3 KB of text. The goal? To see if AI can solve problems like a versatile problem solver, not a one-trick pony. How do researchers measure success? Let's look at datasets. Take BELKA, a library of 2.9 billion chemical interactions. Think of it as a molecular encyclopedia where every entry is a molecule-protein pairing. Researchers sampled 2.2 million examples for training and 590,000 for testing, ensuring fairness. Their metric: the AP score, a report card for how well the AI predicts chemical bindings. Then there's OAG, a dataset focused on academic accuracy. It checks if papers are correctly linked to authors and institutions, acting like a detective catching mismatches. Imagine a teacher flagging a student's name mixed up with another's. The team used 10,000 papers and a metric called PM1Y times OC, which evaluates not just final answers, but how well the AI corrects errors along the way. So how did they build the AI? Two main approaches, AUTOMIND and AID. Think of them as AI problem solvers with distinct strategies. AUTOMIND, for instance, combines models like GPT-4o Mini with custom code, tweaking parameters to optimize performance. It's like giving an AI a toolkit and letting it choose the right hammer or screwdriver for each task. This study isn't just about can AI solve problems, it's about how well and how adaptably. By testing on such a diverse range of challenges, researchers are uncovering where AI excels and where it needs refinement. Whether it's drug discovery or academic accuracy, these findings could shape the next generation of AI tools. AI isn't just getting smarter, it's becoming more versatile. As these models tackle everything from chemistry to academia, the possibilities for real-world impact are immense. Want to see how this all works in code? Stick around for the next video, where we'll break it down step by step. Thanks for watching. Drop a comment if you'd like to dive deeper into how AI learns from data. Until next time, keep exploring the future of machine learning.